Welcome to Dr. Yap Banha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. The problem I've taken from the problem box is about two items. And the two items had the same price. The shop is giving 5% discount for that item, but 15% discount for the other item. Spiky was short of $2 to buy this item. So he bought the other item and had $3 left. Is it possible to find out how much money Spiky had? Is it possible to find out how much each item costs before and after the discount? That's our problem for today. Let's look at the problem again. So that's the discount, and that's what a customer like Spiky had to pay. Toy B had 15% discount. And can you see the amount that customers like Spiky had to pay for that toy? It's here, isn't it? Do you see why Spiky was short of money to buy toy A? Toy A cost that much, and Spiky was short of money to buy it. Can you imagine how much money Spiky might have? Can you imagine the diagram for Spiky's amount of money? Should it be longer than this or shorter than this? By how much? So he bought toy B. So Spiky paid this amount. And as a result, Spiky had $3 left. Can you imagine the bar model for Spiky's amount of money? Can you continue? What's the answer? How can I get an answer if I have started with these bar models? Two toys had the same price, but they have different discounts. Toy A, 5% discount. So we don't have to pay for that amount. A customer needs to pay this amount. Toy B had 15% discount. we don't have to pay this amount. A customer needs to pay that amount. Spiky wanted to buy this one, but he didn't have that amount of money. So he bought this one, paying this amount of money, and he had some money left. Can you imagine the bar model for Spiky's amount of money? I wonder how much money Spiky had. It should be more than this amount, but less than that amount. Perhaps Spiky might have that amount of money? Is that possible? For this to be the bar model for Spiky's amount of money, he wanted to buy toy A, but he doesn't have enough. He is short of $2. Can you see where the $2 is on the diagram? So he bought toy B and he had some money left. Can you see where on the diagram is the $3? Can you imagine where the $2 and $3 should be? I can see where the $3 should be. The $3 should be here in orange, because he bought this and he still had $3 left. What about the $2 on the bar model? Can you see where the $2 should be? I will now show it on my diagram. Can you imagine where on my diagram I'm going to shade to show the $2? Were you expecting me to say that this portion is a $2? So now I know all that is $5. The question is, do we know anything about the $5? Is that right? Some of you are thinking that we do know something about the $5. That's 15% of the original price of each toy. So that must be 15% as well. And if that portion is 5% of the price of the toy, can we say something about that? I think you are right. So we can conclude that 10% of the original price of the toy is actually $5. The $5 coming from the total of the $3 and the $2. And if we know that, can we answer questions like, how much was the original price of the toy? If 10% is $5, the full price of the toy must have been, you are right, $50. And can we find out what is the price of each toy after discount? Toy A had 5% discount. So toy A, the discount is how many dollars? 10% is $5. 5% must be $2.50. $2.50. We often write it like so. So do you see how much a customer needs to pay for toy A? If the original price is $50 and there's a discount of $2.50, toy A must have cost $47.50, isn't it? Can we do the same calculation for toy B? Toy B had a bigger discount of 15%. If 10% is $5 and 5% is $2.50, 15% would be, that's right, just total them up, which is $7.50. So do we know how much a customer needs to pay for toy B with that discount? Original price was $50 with a discount of $7.50. I think you are right. It's just $42.50, isn't it? Can we also answer the question how much money Spiky had? Remember, he wanted to buy toy A, but he didn't have enough. He was short by $2. So how much did he have? That's right, $2 less than this, $45.50. And when he bought toy B, he paid that amount. No wonder he had $3 left. I think we can answer quite a lot of questions from that set of information given to us in the story. If you find today's problem quite easy, there are a few things you can do to challenge yourself. For example, perhaps you're quite unhappy with the fact that the price of the toy is $50. Maybe you think that that's not reasonable. If that's the case, why don't you write another problem where the prices are more reasonable? Can you pose a similar problem but with different numbers so that the price of the toy become what you might consider to be reasonable? Another way you can challenge yourself is to pose a similar problem, but instead of the prices of the two toys being the same, why don't in your problem you say that one toy is more expensive than the other by a certain amount? That's another way you can challenge yourself, by posing a similar word problem but with slightly different conditions. Other things you can do to challenge yourself. Maybe you do not like the way I've drawn the bar models. You may think that my proportions were not correct. You can challenge yourself by presenting the solution with a better diagram, and maybe you can write it up with a note to explain what the solution is all about. Yet another way you can challenge yourself is to solve this problem, but in a different way, using another method. Perhaps using algebra, by letting the original price of each toy being X dollars. And that is yet another way you can challenge yourself.